All right, welcome to week 6 lesson. Go ahead and get started. We're going to talk about quadratic functions today. All right, so anything that's a quadratic function is anything that's shaped like a parabola, right? So we've got this parabola-shaped function here. It could be upside down, it could be shifted over, and all those things. But basically, anytime you project something like you throw a rock or a rocket's launched, anything like that, it's always going to travel in a quadratic function. So there's 3 forms we're going to talk about. The first form is called standard form. All right, so standard form is always in the form f of x equals ax squared plus bx plus c. Now in this form, a, b, and c are going to be numbers. So when you see an actual standard form quadratic function, you'll see like 3x squared instead of a. You'll see a, b, and c will be represented by numbers. Okay, so let's look at an example. If I have f of x equals x squared plus 12x minus 3, right, what would a be? A would be the coefficient of the x squared term. So a would be 1, b would be the coefficient of the x term, so b would be 12, and c would be the number that doesn't have an x attached to it, it would be negative 3. Okay, so be aware that there's things where you might have, let's say g of x equals 3x squared minus 10. Okay, what is a? A is 3. What is b? B is 0. Okay, a lot of people are going to say, oh, b is negative 10. But remember, b is the number that is with the x. So it's almost like if we added a 0x to that, that wouldn't change it, right? If I rewrote this as 3x squared plus 0x minus 10, now I can see, okay, a, b, and c. So sometimes you'll be missing a term. Same thing if I had another function where it was negative x squared plus 4x, right? You'd have to add a 0 to the end here to see your c. A would be negative 1, b would be 4, and c would be 0. Also, it could be out of order. You could have 10 minus 3x squared, okay? A is negative 3, b is 0, and c is 10. Okay, it's got to be, you want to usually write it as x squared and then x and then the number. But you don't have to write it like that, but you just have to be able to remember that c is always the number without any variable, b is the number that's attached to the x term, a is the number attached to the x squared term. Okay, so let's look at a little further into standard form. Let's look at an example here. All right, 3x squared minus 12x plus 11. Okay, so here's how I coach standard form. All right, one thing that we get from standard form is one of the special points is called the y-intercept, and I'm going to show you how to find the y-intercept. But before I do that, I'm just going to look at this function and say, okay, if I wanted to make a table, right, where I have x and y, what would be the easiest number to plug in for x to find the y value? Well, let's see, I could plug in something like 3, and I'd have to do 3 times 3 squared minus 12 times 3 plus 11, and that's okay, I could do that, but that's just a lot of work. There's an easier number that I could pick. The easiest number I could pick here is 0. Because look what happens when I plug in 0 for x. That is 0, that is 0, and that's 11. 0 plus 11 is 11. So if I plug in 0 for x, the y value is going to be 11. Basically, whatever c is here is going to be your y-intercept. Now, like I didn't mention it, but this is the y-intercept, okay? The easiest number that you could plug in for x in standard form is going to give you back the y-intercept. So think about what this looks like. If positive 11, there's a dot right there. So this is approximately what this function looks like. Right there is the y-intercept of 11. It happens when x is 0. Okay, all y-intercepts happen when x is 0. Okay, so that easiest point is gonna tell us the y-intercept. So let's try another example here. What if we have f of x equals 2x squared minus 4x minus 6? Okay, what's the y-intercept? Y-intercept should be -6. When I plug in 0, that goes away, I'm left with -6. So 0, -6 is my y-intercept. Okay? Pretty straightforward there. All right, so the next thing that you can find when you're in standard form is the vertex. So let's look at another example here. If I have 2x squared plus 16x minus 10, I want to find the vertex of this function. Okay, there's a little mini formula that we use to find the x coordinate of the vertex. That formula is -b over 2a. Okay, remember we know a, b, and c when we're in standard form. So in this example, b is equal to 16 and a is equal to 2. So -b would be -16 divided by 2a. So 2 times 2. 2 times a. That's going to give us -16 divided by 4, which simplifies just to be -4. So what that tells me is the x coordinate of my vertex. So if I write the vertex, remember it's the highest or lowest point in the parabola. So if we want to ever find the highest or lowest point in the parabola, the maximum of the function, the minimum of the function, right? If our parabola looks like this, we want to find the highest point, we're looking for the vertex. So that little coordinate right there is the vertex of the function. So we know the x coordinate is -4. We used our -b over 2a formula right here to find that. Now, how do I find the y coordinate? Same way I find any y coordinate. I plug the x back in. So remember, this is saying f of x. So we're going to plug in -4 for x. So f of -4, remember that's just the y value at 4. So the y value is 2 times x squared plus 16 times x minus 10. Okay, when I work this out, I get 2 times 16 minus 16 times 4 minus 10. So I get 32 minus 64 minus 10. That simplifies to be -44. So that tells me the y coordinate of my vertex is -44. So what I did was I found the vertex from standard form. So that's something that you've got to be able to do. When I get given standard form, I can immediately look at it and go, oh, here's the y-intercept, and then I can use a pretty simple strategy there to find the vertex. Okay, so just to review, standard form tells me the y-intercept, and I can use it to find the vertex. Okay. All right, moving on. Next form that we're going to talk about is vertex form. All right, vertex form. Okay, so vertex form looks like this. F of x equals a times x minus h squared plus k. Now in this form, there's 3 numbers. So you're going to have a, h, and k are going to be numbers. So these are numbers. And hk is actually the coordinate of my vertex. Now one thing you have to notice here is in the formula, x minus h squared, right? You see how I have this minus h here, and I have a k. The vertex is hk. It's not minus hk. It's hk. So you've got to remember that the when in the formula, if it says x minus 7 squared plus 10, the vertex is 7, 10. Notice how I use the opposite version there. I use the negative of that. If the example says x plus 1 squared minus 2, then I'm going to say the vertex is at -1, -2. Again, I use the opposite of the number with the x, and I use the same number that's out at the end. Okay? So this form, vertex form, tells me my vertex. Okay? So let's look at an example here. Let's say we have f of x equals -1/2 times x minus 3 squared plus 10. Okay, so here's how this works. Basically, all you have to remember is the same way we did it in standard form. What's the easiest number to plug in for x? Now, last time we plugged in a 0, and let's see what happens when I plug in a 0 for x. -1/2 times 0 minus 3 squared plus 10. So to find the y value, I have to do actually a lot of work here. I have to subtract. That gives me -3. Okay, I have to then square the 3. So I get -1/2 times 9. See, all this is too much work. Ultimately, we want to be able to do this without doing really any work at all. So 0 is actually not a good choice to plug in for x here. Do you see what the easiest number would be? The easiest number would be 3. Because what happens if x is equal to 3? I get 1/2 times 3 minus 3 squared plus 10. What's 3 minus 3? It's 0. 0 squared is 0. Negative 1/2 times 0 squared is 0. So really, we just get 0 plus 10, which equals 10. So that's why I use the opposite of what I see here. If I see a -3, I use +3, because I want to just make a 0 happen, because zeros are easy to work with. And we always get back this number at the end here, this 10. Okay, so let's look at an example here. What if I had the function 2 times x minus 1 squared minus 8? Okay, the vertex is going to be whatever x is easiest to plug in. So you can see if I plug in a 1 here, it's going to be really simple to work with. 1, right? If x is 1, 1 minus 1 is 0, 0 squared is 0, times 2 is 0, and 0 minus 8 is negative. So that's just another way to think about it in terms of the easiest number to plug in. So in vertex form, the easiest number to plug in ends up giving you your vertex, okay? All right, so let's talk real quick about symmetry. So don't forget, parabolas are symmetric. So from the vertex here, there's this line of symmetry, okay? And so basically things that are at the same height, like these 2 points are at the same height, they should be the same distance across, left and right. This point right here, see how it's at the same height as this point right here? It should be the same distance across from this line. So this line is called the axis of symmetry, and it's basically just the x coordinate of the vertex, negative b over 2a. And you'll see that occur in some problems where you can do shortcuts. Like if I knew these 2 zeros, you'd say the vertex is right in the middle. And so you'd know the x coordinate without really having to do a lot of work. In other words, if this thing crosses at 1, and over here this is at 9, and I said, what's the x coordinate of the vertex? You would say it is 5, because it's 4 over to get to 9 and 4 over to get to 1. So that's one way you can use that symmetry, okay? All right. Well, I guess one more thing about the symmetry. If I had this, right, 0, 2, 10, 2, 0. If I had something like this, you would notice, see the symmetry, how it's the same on both sides? That means that this is my vertex. So you can look at a table and know where the vertex is if you have that symmetry around it. Okay? All right, very good. All right, next form, it's going to be factored form. All right, so factored form always looks like this. F of x equals a times x minus r1 times x minus r2. So r(a) and both of the r's, r1 and r2, are going to be numbers. Okay? That's how you'll be able to tell. It's kind of hard to see that. I know my face is in the way here. So there we go. A, r1, and r2 are going to be numbers. Okay. So let's look at an example. We have f of x equals 3 times x minus 6 times x plus 1. All right, there's an example. So we're going back to this idea of what's the easiest number to plug in for x. Well, if I plug in a 0 here and a 0 here, it actually makes it kind of difficult. I have to do 3 times a number, and I have to really think about what's going on there. But what if I plug in x equals 6? It becomes 6 minus 6 times 6 plus 1. Now what's easy about this is going to be 0. So 3 times 0 times 7 is 0, because I multiplied something in there by 0. So that tells me that the y number will be 0. What is the other x number that I could pick to make a 0 happen? You see how negative 1 would work? Because I'd have 3 times negative 1 minus 6 times negative 1 plus 1. This is 0. So 3 times negative 7 times 0 is going to be 0. So those easiest numbers to plug in are what make the function equal to 0. We call these our x-intercepts. Now, what does it look like on the graph? Well, right here I have 6, 0, that's right here, and I have -1, 0, which is right here. Okay, so basically this is the shape of my parabola. Okay, they're x-intercepts, they're the locations where the graph crosses the x-axis. There's also several names for this. We also call them zeros. We also call them roots, and even sometimes we call them solutions. Okay, so just be aware, it's really important you know all these names. X-intercept, zeros, roots, solutions, they're all the same thing. It's the numbers that you plug in for x to get a y back of 0. Okay, all right, so let's look at an example. Find the x-intercept if f of x equals 2 times x minus 3 times x plus 1. Okay, so you're working this problem, you're like, okay, what's the easiest number to plug in for x to make a 0? Well, I can see that 3 and -1 are both numbers that would make this whole thing equal to 0. So these are my x-intercepts. Also, they're called roots, zeros, and solutions. So what happens if your factored form looks something like this? Like one of your factors is weird. I can see that 1 would be the easiest number here. What number would I plug in for x here to make the whole thing equal 0? Make this whole thing equal 0. Sometimes it's not easy to tell. 3 times some number minus 2 is 0. I don't immediately know that necessarily. So what you do when you get it in factored form is you set the factor equal to 0, and then you solve that equation. So I'm going to add 2 to both sides. That's going to give me 3x equals 2. My last step would be divide by 3, and I realize that 2/3 is the number that makes that 0. So 2/3 would be my 0, or my x-intercept, or my root. Okay? So just be aware if one of your factors has a coefficient in front of the x, you just set it equal to 0 and solve. And we'll work more on that next week when we're working on solving. Okay. So let's talk about a. If you look back at all three of these forms, right, we had a times x minus h squared plus k, right? That was vertex form. We had ax squared plus bx plus c. That was standard form. And then we had a times x minus r1 and x minus r2. Do you notice how they all had an a in there? That means something actually very specific. These a's are all the same number, okay? These a's are found in all three equations, and it's really important that we understand what the a does. Okay, so let's look at a equals 1. All right, if a equals 1, here is a parabola where a is equal to 1. All right, so what happens is, if you start at the vertex, right, we have a little dot here. If you travel over 1, you will go up 1 to the next point. From the vertex, over 1, up 1 in both directions. So this number here is what's important. You always go over 1 in both directions. Like these ones here are always the same. You always go over 1. The question is how far up or down do you go to find other points? That's what a tells you, okay? So if a was equal to -1, okay? Our vertex is right here. What that tells me is I've got 2 more points. I go over 1 in either direction, and then where do I go from there? Well, if a is -1, I go down 1. And when I travel down 1, there will be another point down here, boom and boom. So then my parabola goes through those 2 points. Okay? Over 1, down 1. Over 1, down 1. I go down 1 because a is equal to -1. Okay? What if a is equal to 3? Right? We've got my vertex right here. The graph is going to look like this. Now let's think about it. Remember when a is 3, what that's telling me is from the vertex I go over 1, up 3, and there's another point. Over 1, up 3. So that means I go up 3. So again, you're seeing the relationship between a and how far up or down you go from the vertex. It doesn't work from somewhere else. Only from the vertex do you go over 1. Remember, you always go over 1. And then a tells you how far you go up to find 2 more points. So what if a was equal to -1/2? Okay, it should work the same way. Got your vertex here at the center. A is going to look like this. It's going to look wider than normal because I go over 1, down 1/2. Over 1, down 1/2. Over 1, down 1/2 because a is -1/2. All right, that's how a works. You can really utilize this to your advantage. It's really important that you know this on the test. Just remember, basically, if A is positive, we notice that it always goes up. So we say it opens up. If A is negative, it's going to open downward, and it's going to look more like these two here. Okay, this opens down because it goes down. Okay? All right. So the next thing I want to talk about is, let's go back and look at the three examples that we just worked. Okay? So we had 2x squared minus 4x minus 6. Let's review. What form is this? This is standard form. Okay? It tells me the y-intercept. The y-intercept is -6. That means down here at -6, there's a dot, and the equation goes like this. Okay? That's what that tells me. All right, let's look at this other form. 2 times x minus 1 squared minus 8. Right? This is, let's see, let's mark this. This was standard form. This one is called vertex form. And what does it tell us? It tells us the location of the vertex. So the vertex is the easiest number to plug in, would be 1. When I do that, I get back a -8. So 1, -8 is the location of the vertex. So here is basically what the parabola looks like. Okay? All right, the third form we talked about was factored form. And our example was 2 times x minus 3 times x plus 1. This was factored form. And what does factored form tell us? It tells us the location of the zeros or the roots. That's why we use r in that formula, or the x-intercepts, either way. Remember, it's the easiest number to plug in here to make a 0 and here to make a 0, so that's +3 and -1. So here's what the graph looks like. Okay, so what I was trying to show you here is that if you look at these three equations, they're actually the same equation. They represent the exact same graph. These graphs are identical to each other. All three of these graphs are actually supposed to be the same. I know I didn't draw them very well, but that's the idea, is that they're actually the same. If you made a table, you would see the tables are identical. Every x and y coordinate are the same in both, okay? But notice the vertex, right? 1, 8, 1, -8, excuse me. If I plug in 1 into standard form, I'm gonna get -8. If I plug in 1 into factored form, I'm gonna get -8, okay? It's easiest to plug it into vertex form, right? When x is 0, the y-intercept is -6. I could get that from plugging it into any of these three forms. If I plug in 0, I'm gonna get -6. It's just easiest to plug it into standard form, okay? These two roots, -1, 0, and 3, 0. Or, yeah, 3, 0. I could plug that in, -1 or 3, into each of these three equations. I'm gonna get back a 0 no matter what. It's just easiest to plug into factored form. So that's the idea, is that you can transfer from one to the other. It's totally doable. So real quick, I just wanted to remind you, you can rewrite these three different forms in any of the three ways you want to, okay? So I'm gonna make a little chart here. We're gonna transfer from a form to a form, and then I'm gonna tell you how to do it, okay? So let's start with factored. Okay, if we have factored or vertex form, either one of those, if I want to convert those into standard form, okay, from vertex or factored to standard form, how do you do it? Well, you just multiply and simplify. Okay? What does that look like? Well, factored form, x minus 3 squared plus 10, right? If I want to get it into standard form, I just multiply out. So that means multiply this thing here twice, and then you'll add 10. So you'll distribute, get x squared minus 3x when you distribute this, plus 9, and then you add the 10. Then you simplify, right? So we're going to multiply and then simplify. So we get x squared minus 6x plus 19. Now we're in standard form. Okay? So basically, either factored or vertex, it would work the same way if you had x plus 1 times x minus 6, right? You just distribute, multiply, simplify. It will be in standard form. Okay? So the next one. All right, what if I want to go from standard form to vertex form. Now, a lot of the times we learn this process of called completing the square in Algebra 2. You could do it, but I wouldn't recommend it. So what I would do is I would use x equals negative b over 2a to find the vertex. So I would use that standard form to find the location of the vertex, right? You get your x, you plug it back in to get your y. Then I would just write it in vertex form. So example, x squared plus 6x minus 10, right? The vertex would be negative b, so negative 6 over 2 times 1, which is negative 3. So negative 3, when I plug in negative 3, I get 9. When I plug in negative 3 here, I get minus 18, and then I get minus 10. So that simplifies to be minus 19. So that means that negative 3, negative 19 is my vertex, okay? Then all you do is write it in vertex form. Remember, vertex form is a times x minus h squared plus k, where the h and k are the x and y coordinates of the vertex. The only thing you got to know is a. We'll steal the a from over here, right? Ax squared. Well, a is 1. So that means in vertex form, it's x minus your h. Don't forget you're subtracting a negative 3 there. I plug in my h, which is a negative 3. That gives me a plus 3. And then plus your k. So this would be the vertex form. So write in vertex form and you steal the a from the other form, okay? So use your vertex, x equals negative b over 2a to find the vertex. Then just take that vertex, plug it into the form, and use the same a that you had from standard form. That's the easiest way to write it in vertex form. Okay, there's one more here. I don't have room, but I'm gonna go ahead and write from, to, and how. So what if I wanna go from standard form? I wanna go to factored form. This is the easiest one. All you gotta do is factor, okay? From standard form, you factor. So if I had x squared minus 3x minus 10, that's standard form. I want to go to factored form. All I do is I rewrite it as x minus 5 times x plus 2. Okay, pretty straightforward. All right, so now let's quick talk about how to use your graphing calculator. So using your graphing calculator, you should be able to find 3 things. You should be able to find the vertex. You should be able to find the zeros, which remember are also called your x-intercepts or roots or solutions. You should also be able to find your y-intercept, okay? Now remember, if you're in vertex form, the vertex is easy. You don't have to think twice about it. You just get it. If you're in factored form, you get the zeros without thinking about it. If you're in standard form, you get the y-intercept without thinking about it. But what if you're in a different form? What if you're in factored form and you want to find the x-intercept or the y-intercept? Well, instead of changing it from one form to the other, just use your graphing calculator. Okay, so that's what we're going to do right here. I'm going to show you how to do that. So let's take any equation here. Here's an equation right here. All right, I've graphed it. I went ahead and typed it into my graphing calculator, and then I graphed it. So let's look at the 3 things. First thing I want to be able to do is find the vertex. All right, so you got to really become familiar with this second trace button. This is your calculate button. I'm going to go ahead and clear my key history here. You'll be able to see it down below. Second trace is calculate. So if I want to calculate the value of this function, I can plug in any number I want. It'll tell me what number comes back as a y value. So remember, when I plug in 0, I get back my y-intercept. So that's where I'm going to use value for. So if I hit enter, choose the number 1, I'm going to say x is equal to 0. When I hit enter, it's going to tell me the y-intercept of 2. Now remember, this would not have been much of a difficult problem because I'm already in standard form and I know that my y-intercept was 2. But let's pretend it was written in a different form. You do the same process, okay? So let's review that. Second, calculate. Number 2, you plug in 0 for x, you hit enter, it's going to tell you the y-intercept there, okay? All right. The next process is going to be how to find the zeros or the roots. all right? But I'm gonna call them zeros because your calculator calls them zeros. So second trace, that's calculate. Number 2 is 0, so hit number 2. Now here's where it has to do a little bit of work. If I can move left or right here. You don't want to really move up or down because that changes functions, and it won't really let you go up or down here. But left or right, it'll let you move left or right. So you see how the 0 is right about there somewhere? And there's another one over here, okay? So what you got to do is see how it's asking right now for the left bound? Let's clear this off. Let's do second calculate, number 2, the 0. It asks for a left bound. So pick one. Let's start with the left 0, okay? Left bound means it wants to make a left boundary. So you have to make sure you're to the left of where your 0 is, and you hit enter. Now on my calculator, it makes a little dotted line. That's the newest version. Some of them won't do it. Some of them will just put the little triangle that you can kind of see up here. This is to the left of where the 0 is. It's called a left boundary. It is to the left of where the 0 is. Next thing it asks for is right bound. Make sure you're to the right of the 0 and then hit enter again. Now see those two little thin strips? The calculator is going to search within those 2 strips for a 0. Now when it says guess, you don't really have to, but you can get close to the 0 and hit enter. You don't have to get close though. You could just hit enter at that point. And there it is. There's my 0, 0.25 or 1/4. Okay? So the 0, one of the zeros to this function is 1/4. Now to find the other 0, I need to do the same process. So second, calculate, number 2, 0. Now I need to do a left boundary. So kind of go over to where the 0 is, and then basically just hit left a few times. This ensures that you're to the left of that 0. Hit enter. There's my left boundary. Go back up to the 0 and then hit right a couple times and hit enter. That will make sure you're to the right. You see how this 0 is right in between my boundary lines? It's going to search within those boundary lines for your 0. So when you hit enter a third time, right, because it says guess, you hit enter, it's going to say 2. So that's the other 0. Okay? That is the process of finding the zeros of a function. Now, thirdly, we want to find the vertex. Okay? So that's the minimum. That's the lowest point now. If it was flipped upside down, it would be the maximum. So depending on which way your graph goes, either down and up or up and down, whether there's a top or a bottom, depends on whether you're looking for the maximum or the minimum. So in this case, we're looking for the minimum. So same thing, second trace, number 3 is the minimum. So I go down to number 3. Now the same thing, left bound, right bound. So go down to where you think the 0 or the minimum is. Hit left a few times to ensure that you're to the left, hit enter. Make sure you're to the right, hit enter, and then go back down to the minimum and hit enter one more time. This will be your guess. There's your minimum, 1.125. Now see how it says 0.00009? Ignore that part. That's a little bit of a rounding error that happens when the calculator calculates this minimum point. Okay? So those are the processes of using your graphing calculator to find those 3 things. Remember though, if you're in a form that tells you something really easy, don't worry about that. Just use the form for what it can tell you. If you're trying to find something different, that's when you would use your calculator. Okay? All right, so moving on. All right, let's talk about factoring. Okay, this is a process you've probably done a million times. If you haven't, it's still good to review it. Either way, it's good to review because it's one of those things that if you can be faster on, it'll save you time on other parts. So first off, let's just factor something really, really easy. Let's factor the number 35, okay? What are the factors of 35? If I said factor 35, what would you do? Well, 7 times 5. That is the factorization. We call it the prime factorization because they're both prime numbers of 35. So what are we doing when we factor? We're taking something and we're rewriting it to where it's a product of 2 things. So this times this, okay? That's what factoring ultimately is. So if I said factor 101x, you'd say, well, that's just 101 times x. That's factoring. We're rewriting it as the product of 2 things. All right, so let's factor. Actually, before we actually factor something, I want to show you where it kind of comes from. So let's do this here. Let's take something that's already factored and let's go ahead and multiply it out. Okay, this has already been factored. It's the product of 2 things. Let's see what we get. So I multiply my x's. What do I get when I multiply my x's together? x times x is x squared, okay? What happens when I multiply x times 7? I get a positive 7x. What about 3 times x? I get 3x. And finally, when I multiply 3 times 7, I get 21. Okay? Now I'm writing it with these colors on purpose here. Okay, so I rewrite this. That's just x squared. This is going to be plus 10x, and this will be plus 21. Okay, so where does the 21 come from? Well, it comes from the product of 3 times 7. Okay, 3 times 7 is 21. Where does the 10 come from in the 10x? Well, look, it comes from this 7 and this 3. When we multiplied by the x, we got a 7x and a 3x. So ultimately, it comes from the 3 and the 7, but it's the addition of those two things, right, to make 10. This is the key to unlocking this. So let's say I gave you this problem right here, okay? If I gave you x squared plus 10x plus 21, and I said factor it, okay? First thing you need to do is figure out these two numbers, the 3 and the 7. You want to find numbers that multiply to be the C term here, this last number, that at the same time add or subtract to be this middle term, 10x. Well, the numbers that do that are 3 and 7. So once you found those two numbers, 3 and 7, then you would write this. You would say, okay, x plus 3 times x plus 7. Okay? I call this the magic numbers game. It's just a puzzle, and it's kind of fun. It's, you know, not horrible at least, and it helps you factor things. You're just playing this number game. I want to multiply to be this number and add to be this number. Okay? All right, so let's look at an example of this. Okay, let's try to do one. Let's try to factor x squared plus 7x plus 10. Okay, so remember, I want two numbers that multiply to equal 10, that add to equal 7. So what two numbers multiply to be 10 that add to be 7? Let's see, I could do 10 times 1, that makes 10, but does it add to be 7? No, it adds to be 11. What about 5 times 2? That makes 10. What does it add to be? Ah, it adds to be 7. So that means 5 times 2 is going to be my magic numbers. So I put x plus 5 and x plus 2. That is the factorization of x squared plus 7x plus 10. It's that easy. Okay, now let's say you're working a factorization problem and you're done and you're like, man, I don't know if I got that right. I think I might have got it wrong. I'm not sure. How do you check yourself? Well, how did we know that 35 was 7 times 5? Well, multiply the things together. What do you get? Well, did you get the same thing you started with? If you did, then you did it right. Okay, so we could check our work here by just multiplying out and saying x times x is x squared, x times 2 is a plus 2x, 5 times x is a plus 5x, and 5 times 2 is 10. Middle terms will combine because they are like terms, and I get this right here. Is that back to where I started? Yes, which means this is actually the correct factorization. So the point I'm trying to make here is you can always check your work by multiplying back out. If you get back to where you started, then you know you did it correctly. All right, let's try a couple more examples here. Let's try factoring x squared minus 3x minus 4. All right, looking for two numbers that multiply to be -4, that at the same time add to be -3. This one's a little different. They multiply to be -4. The only way two numbers can multiply to be a negative is one is positive, one is negative. So in this case, we actually want the two numbers to subtract to be -3. Well, 4 and 1 multiply to be 4, and they subtract to be 3 if I do the signs correctly. Which one would be negative? I think it'd have to be -4. Because -4 plus 1, that's -3. If you tried it with the negative, you could try it by flipping it around. You could say, what if it's -1? And you'd see that you don't get -3. So if you don't get -3, then you know that you're supposed to have done the -4 and the positive 1. So once you figure out those numbers, it's straightforward. You put those numbers next to x's with plus or minuses, whatever their sign are, and that's the factorization. It's that easy. All right, let's try one more. X squared minus 13x plus 10. Two numbers multiply to be 10, add together to be -13. let's think about this. If they multiply to be 10, they could both be positive, because two positive numbers multiply to make a positive 10. They could also both be negative. Negative number times a negative number would actually make a positive. The question is, do they both have to be positive or both have to be negative? Do two positive numbers add to be a negative 13? Is that possible? No, that's not possible. Two negative numbers would multiply to be negative 13. So they both have to be negative. So let's look at all the factors of 10. All right, we have 10 times 1, we have 5 times 2. Those are the only factors. Remember, they both have to be negative. So these combine to make negative 11. These combine to make negative 7. Do either of those make negative 13? No. Well, those are all the factors of 10. That means this thing is not factorable. Sometimes you get this. Sometimes you get where they don't factor, and that's okay. There's other strategies to solving this thing other than factor. Okay? All right. So moving on, continuing with factoring. This is a really important idea. It's called the greatest common factor. So GCF is this process that we really should be looking to do every single time we factor. If you factor any time, you should always look for the GCF. Okay? So basically always factor out GCF if possible. At the very beginning, do it from the start, okay? It always makes things easier. So let's look for an example, x to the third minus 3x squared minus 18x, okay? X is in everything, right? There's an x in the first term. There's an x in the second term. There's an x in the third term. That means x is a common factor, okay? So what you do is you factor it out. You pull it out front. And when you pull it out front, you're really dividing each term by that. Because then when you distribute back in, you're multiplying. So we're doing the opposite. We're pulling it out. So we got to be thinking about dividing. So when I divide out the x into x to the third, I get x squared. When I divide out an x here, I get minus 3x. When I divide an x out here, I get negative 18. Now again, this is factoring out the GCF. So we're factoring. You can always check your work by distributing back in, right? If I multiply back in and I get the same thing I started with, which if you multiply x times x squared, you do get x to the third. If you multiply x times negative 3x, you get negative x squared. And if you multiply by negative 18, you do get that. So we know we did that correctly. You can always check your work. Now here's the thing with GCF. A lot of the times you'll factor out a greatest common factor and you won't be done. You're supposed to factor again. So don't stop there, right? After you factor out the greatest common factor, you want to then look for another chance to factor. So this can be factored into two things that multiply to be negative 18 that add to be negative 3. Let's see, 6 and 3. 6 and 3 multiply to be 18 and they subtract to be negative 3. So that would be the complete factorization, but remembering to do GCF first, okay? So let's look at another example of using GCF. All right, so factor this using GCF. Greatest common factor. Well, you see how the 2 the 2x squared has a 2 in it. The minus 4x is a multiple of 2. 6 is a multiple of 2. There's a 2 in all three of these terms. So what that means is we pull the 2 out front. So if we pull the 2 out of the 2x squared, what's left? Well, just an x squared. We pull the 2 out of the negative 4x, what are we left with? Negative 2x. Pull the 2 out of the negative 6, we're left with negative 3. Okay? Now again, I could check my work by distributing that 2 back in. Multiply it back in there. You'd see that I get the same thing that I started with. So you're like, okay, I did it right. I factored correctly. Now, once you pull the GCF out, try to factor it again. So two numbers that multiply to be negative 3 that add to be negative 2, that would be negative 3 and positive 1. Okay. Again, you can check that by multiplying back out, but it should work. So that is your completely factored version of that problem. All right, last one we're going to look at here, negative x squared plus x minus 6. Sorry, got that wrong. Negative x squared minus x plus 6. Okay. Now this doesn't look like there's a GCF, but you see how that negative sign is in front of the x squared? We don't want to factor it with a negative sign in front of the x squared. It gets pretty messy and kind of confusing. So I'm just going to pull out a negative 1 to get rid of that negative 1. So I'm going to factor out a -1. Now remember, really what I'm doing is dividing by -1. So when you divide by -1, it doesn't change anything but the sign. It just switches the sign like a light switch, turns it on or off. Negative, positive, positive, negative. So what does that -x squared become? It becomes positive x squared. What does the -x become? It becomes positive x. What about that positive 6? It becomes -6. Now take a second here to check. If you distribute that -1 back in there, do you get the same thing you started with? I don't know, let's look at it. What's -1 times x squared? It's -x squared, which is what we have here, okay? -1 times x is -x. -1 times -6, +6. So we really do get back to where we started, which tells us that we did it correctly, okay? All right, so remember, don't ever stop there. You want to keep trying to factor this. Two numbers that multiply to be 6 are 3 and 2. And what will they add or subtract to be +1? I'm going to need a +3 and a -6. That way they multiply to be -6 and add to be +1. So there's our factorization. Okay. All right, not too bad. All right, so just remember the whole point of GCF is that you always try to do it first. You should never, ever, ever factor without trying to pull out the greatest common factor. I promise you, I've never once said, man, I wish I didn't do that. It always makes things easier, and that alone is enough reason to do it, okay? All right, so in all the past examples, we've looked at things where we've been factoring, but the idea is that A has always been 1. So it's always been 1x squared, blah, 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 blah. 1x squared, blah, blah, blah. We never saw anything where it's 3x squared, blah, 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 blah. Now we're going to look at that example. So we're going to say what happens when A does not equal 1. Remember, A is the number in front of the x squared term. So if A does not equal 1, try to pull out a common factor. Try to pull out that GCF, okay? If there's no GCF, or if after pulling out the GCF, there's still A is not 1, then we've got to do something different. We've got to try something crazy, okay? Now there's a couple different ways to do this, but I'm going to show you a way that works every time. It's weird, but you just got to follow along with me here. Okay, so I have 2x squared plus x minus 3. So I try to pull out my greatest common factor. I realize there is no greatest common factor, so really in this problem, A is still not going to be 1. So I have to do something different. So first thing I tried to do was pull out the GCF, the greatest common factor, but there wasn't one, and that's okay. Then what I do is I multiply A over to C. So that number in front of the x squared gets multiplied over at the end. So I'm going to multiply over A. And we're going to multiply it over to C. So I multiply the A over there times the C. Now what does that give me? Well, the 2's gone, actually. The 2 moved when I did this, and it leaves me with -6. Now what we just did was we broke every kind of math rule there is. But you got to make sure that when you do this, you do it very specifically. We just broke a rule. All right, but it's okay. It's going to work out. Third step is factor like normal. Okay, just like a normal equation here, I'm going to factor like normal. So two things that multiply to be -6 that add to be +1. Multiply to be -6, add to be +1. That's going to be +3 and -2. All right, fourth step. We're going to divide back the A. So in our case, the 2. Now we're going to do it twice. So this A that we moved over, right, this A gets divided here and divided here. The way I multiplied it over, when I factor, I've got to divide it out twice. Okay? All right, fifth step, simplify the fractions. So right here, right? 3/2 stays as 3/2 because it doesn't simplify. But here, 2 divided by 2 simplifies to be 1. So 2/2 can be written as 1. So that's what I mean by simplify the fraction. All right, last step. And then we're done. All right, any remaining denominators move over. So if there's a denominator, remember denominator means the bottom, denoms. If there's a denominator left over here, you got to move it over to the front of the x. So we're going to say 2x plus 3 times x minus 1. And that's it. That's the factored form of this quadratic equation from the very top. You could check it by multiplying it out, look at the same thing you started with. So first step, pull out the greatest common factor. If there is one, you got to pull it out. This will not work if you don't do it. Second thing, you multiply over that a, right? You multiply this number over here. Multiply it over. That gets you to here. Factor like normal. Divide by the a on both parts, and reduce. If you don't reduce, it's going to mess it up too. Okay, you've got to reduce the fraction. After you reduce the fraction, then you move any remaining denominators over and you're good to go. Okay, that's the process. All right, so let's try an example here. 8x squared minus 2x minus 3. Okay, you want you pause the video and try to work this one, see if you get the same answer I get. Otherwise, let's just work it. All right, multiply over your a. So we get x squared minus 2x minus 24. Factor like normal. The two factors are, let's see, 6 and 4 are the two numbers that multiply to be 24 that add to be -2 as long as the 6 is negative and the 4 is positive. That a that I divided, or that I multiplied, I'm going to divide back. Reduce my fractions, that's 3/4. And this is 1/2. Then I move over my denominators. 4x minus 3 times 2x plus 1. That's the factorization. So once you figure out how to do it, it's pretty easy. You just got to learn how to do it. All right, last factoring thing I'm going to talk about is a difference of squares. So how this works, let's say I have x plus 1 times x minus 1. Okay, if I multiply this out, I'm going to get x squared minus 1x plus 1x minus 1. Okay, what happens to the middle terms? Minus 1x plus 1x goes to 0, makes 0x. So I'm left with x squared minus 1. So the goal is to look at this and go, I know how to factor that. This is a difference of squares. Something squares to be x squared. What is it? Well, it's x, right? X squares to be x squared. What squares to be 1? 1. 1 squares to be 1. So the idea is that you have two things that are ultimately being able to be squared to be the two things in your factorable function. And what you do is you put 1 with a plus and 1 with a minus. It's that easy. All right. Now with a problem like this, you could also rewrite x squared minus 1. You could rewrite it as x squared plus 0x minus 1 and think of it as our normal magic number scheme. What two numbers multiply to be -1 that add to be 0? It's got to be 1 and -1. That's why we get x minus 1, x plus 1. So you could think of it that way. But ultimately, the problems can get harder to where you're kind of forced to think about it a different way. So let's look at an example of an easy one. B squared minus 49. Okay, you notice how this is something squared, it's b squared. This is something squared, it's 7 squared. It's a difference of squares. Remember, difference means subtraction. So I have something squared minus something squared, easy to factor. You take the two things that are being squared, add them, multiply them by the subtraction of the two things, and that's it. Okay, you got to figure out what is being squared to get b squared, and what is being squared to get 49. Then it's easy. Now remember, you could always check. This gives me b squared minus 7b plus 7b minus 49. These two terms go away, and we're left with b squared minus 49. So we did get back to where we started, which all that tells me is that I factored correctly. Okay, all right, let's try another one. X to the 4th minus 1. Okay, so x to the 4th minus 1 is a difference of two squares. Now, what is it that squares to be x to the 4th? It's not x this time, because x times x is only x squared. We need more. Well, we need x squared, right? X squared times x squared is x to the 4th. What squares to be 1? That's a 1. So I found my two things that square to be my difference of squares. So what I do is I put 1 with plus 1 with minus, okay? Now you're not done. When you factor, you should always look to factor again, because maybe what you factored it into is factorable. Kind of like when I factor 100, right? I can say it's 50 times 2, that's right. But 50 is not done. 50 can be factored. So you'd want to factor it down to 25 and 2, and then factor it down to 5 and 5. So you want to make sure you keep factoring until you're not able to factor anymore. So right here, I see 2 terms. So I maybe think, oh, difference of squares. There's only two things there. Problem is, this is not a difference. This is a plus, a sum of squares. We don't have a formula for that. But over here, I have 2 terms with a difference of 2 squares. What is it that squares to be x squared? Well, it's x. What squares to be 1? 1 squares to be 1. So there we go. That's my difference of squares. I have 1 with a plus, 1 with a minus, and then don't forget you've still got this other factor there. So this is actually the complete factorization of x to the 4th minus 1. If you wanted to check your work, you can multiply this back out. You'll get the same thing. Or if you wanted to use testing strategies from week 2, you could pick x equals a number, and you would see that x to the 4th minus 1 and this factorization are the same no matter what x you pick. I could pick x equals 10. 10 to the 4th minus 1. 10 to the 4th is 10,000. Minus 1 is 9,999. If I plug in x equals 10 here, and x equals 10 here, and x equals 10 here, I'm going to get 9,999. That's another way to show that 2 things are equal, is if for every x, they're equal. That's what it means to be the same thing. Okay? All right, let's try a hard one here. 4a squared minus 16b squared c to the 4th. Now, what squares to be 4a squared? What times itself is 4a squared? It's kind of crazy, but it's 2a. 2a times 2a is 4a squared. Now, here's the crazy one. What squares to be 16b squared c to the 4th? It's 4bc squared. Think about it. 4bc squared times 4bc squared. If you square it, what do you get? 16. b times b, that's b squared. C squared times c squared, that's c to the 4th. You really do get that. So once you have your 2 things, you write 1 with a plus, 1 with a minus. That's it. Now look here, this could be a difference of squares, but nothing squares to be 2a, nothing squares to be 4bc squared. It almost does, 4bc squared at least, but that's it. So that's our factorization. All right, so that's difference of squares. So why do we factor? The reason we factor is we want to be able to solve equations that are quadratic, and we'll learn next week about how to actually do that. So just know that's why we're factoring, okay? All right, so one thing I want to talk about real quick is if I have a function that I have the graph for, if I'm given a graph of a function, I want to be able to use what we talked about, these 3 forms, to be able to write the equation, okay? So let's say that I have a vertex right here at 2, -1. And let's say I want to write the equation of this. So first off, vertex form is a times x minus h squared plus k, right? H is the x coordinate and k is the y coordinate. Well, what's the x coordinate? X minus 2 squared plus a -1. So remember, because it's a plus a -1, I'm actually just going to write -1. Problem is I need to know a. Well, we know how to deal with a, right? Remember, a is basically how far when you go over 1, how far you go down. So it looks like to me that we go down to here, which looks like 1, 2, 3, 4, -5. So that means a is -5. So our equation is -5x minus 2 squared minus 1. So I can come up with the equation just by giving a graph. Not a lot of people can do that. So another way you could use is transformations, right? Think of this thing as x squared, which is like this. How do I get from here to here? Well, I shifted right 2, right? I went right 2. And then I went down 1. So right 2, remember when it's with the x, it's left to right and it's backwards. So a -2 would shift it right 2. This shifts it down 1. This flips it upside down, and this stretches it by a factor of 5. So instead of going over 1 down 1, I go over 1 down 5. So you could think of this as transformations, or just think of it as vertex form. But either way, this problem's pretty easy. You won't, like most people on the test, they'll sit there and they'll use their calculator, their graphing calculator, typing in 5 different graphs, trying to find which one. And you're already on the second problem because you knew how to use vertex form. So vertex form is a great way to use a graph to come up with the equation, okay? All right, so let's look at one more example here of doing that. So got a graph here, and we've got this function. So it's right here, and here's what it looks like. All right, so I want you to pause the video, see if you can come up with this equation, and see if you got it right. All right, so looks like the vertex is at -2, -1, and looks like my A is over 1, up 1, 2, 3. So +3 would be A. So A is equal to 3. That's all I need, right? Remember A times x minus h squared plus k? Well, it's 3 times x plus 2. You see why I did plus 2? Because it's minus h, and minus -2 is actually a plus 2, squared plus minus, I should say, 1. That's the equation of that graph. 3 times x minus 2 squared minus 1. Okay, pretty easy. All right. So last thing I want to talk about is quadratic inequalities, okay? All right, so quadratic inequalities are actually pretty easy. Here's how it works. Basically, you solve for the quadratic equal to 0. So solve with it equal to 0, not less than or greater than like it starts with. You solve with equal to 0, right? You plot your 2 solutions, and then you test points. So either you're going to have this, where it's everything shaded in between, or you're going to have where it's shaded on the outside. So basically just pick a point either on the interior or the outside of these 2 points. If it works, you shade to the outside if you picked an outside point. If not, you shade away from it. It's pretty straightforward. So let's work an example here. X squared minus 6x plus 8 is greater than 0. Okay, so remember, solve it with an equal sign first. This is going to find these endpoints. Okay, so remember the way we solve quadratics, one way is by factoring. So we say, okay, -4 and -2, that means 4 and 2 are the numbers that work. Those are my zeros. So I plot these 2 points on a graph, 2, 4. Since it's greater than and not equal to, we're going to do 2 open circles here on my endpoints. Now, it's either in between there, like that, or it's to the outside, like this. Those are my 2 options here, all right? So all I got to do is test a point. I would like to test 0, since 0 is easy, easy, easy to test. Now 0 works, I'm shading the outside, because 0 is on the outside. If 0 doesn't work, I'm shading on the inside, because it's not on the inside. So let's try the very first equation, right? I'm going to take this equation, I'm going to plug in 0. So 0 squared minus 6 times 0 plus 8 is greater than 0. I get 0 minus 0 plus 8, that's 8. Is 8 greater than 0? Yes, which means 0 is a solution. So that means I want to shade towards that point. So I shade everything to the left here, and then I shade everything to the right. Now, if you weren't sure, you could test a point like 5. 5 is also going to work, 10 is going to work, 100 is going to work. Everything over here is going to work. What's not going to work is this region in between. That's not going to work. So this is going to be the graph of my solution. All right, so one thing to also think about here is that if you had a bunch of answer choices, right, where you had a bunch of graphs, and there was maybe some in the middle, some that were outside, some that had different points, you could test different points and just guess and check, right? You could test points and figure out which of those answer choices worked. Alternately, you can use your graphing calculator here. Remember, anything that's an equation or an inequality, we can graph using our graphing calculator. So I'm going to graph the left side of that inequality and the right side and see how it says greater than. I want to know when the left side is bigger than the right side, okay? So I graph the left side. Left side is x squared minus 6x plus 8. And the left side was 0. So I want to know when the left side is bigger than the right side. First of all, I can look at the table, right? When is the left side bigger? Looks like at -5 it's bigger, -4 it's bigger, -3 bigger, 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 bigger until I hit 2. They're equal at 2. And then 3 it's smaller, right? The left side is smaller, and then back again the left side is equal. So this shows you that between 2 and 4, the left side is smaller. So we want everything other than that. We want to know when this is bigger. Now, if I look at the graph, I can do the same thing. I can say, oh, look, the first line that I graphed is smaller in between 2 and 4, and over here it's bigger, right? Bigger, bigger, bigger. So everything to the left of 2 and everything to the right of 4 is going to be my solution set. And that's exactly what we have right here, okay? So don't forget that option as well. All right, very last thing. We're going to look at a 2-variable inequality. So something like x's and y's. So for example, if it said to graph y is less than or equal to x squared plus 3x plus 2, how would we graph that? Okay, first thing, we graph it like normal. So you can get your graphing calculator out, or you could factor this into x plus 2 times x plus 1 and realize that your zeros are at -1 and -2, and that your graph basically looks like that. Now again, seriously, it's not that hard to just plug it into your graphing calculator. Y equals, type it in, bam, you're done. I'm just showing a quick way to think about it in terms of factoring using the zeros. It's really easy. So the question is, this is a shading. So we either shade, excuse me, everything above the line, or we shade everything that's below the line. It's either one of those. So here's one thing. If it's y less than, it's below. Easy as that. If it's not y solved for, you have to test a point. And any point would work, but I like 0, 0, right? 0, 0 is always a good choice, right? Test 0, 0. So you've got this equation, okay? You're going to plug in y equals 0. And see if it works. Does 0, 0 work? 0 less than or equal to 0 plus 0 plus 2 is 2. Is it true that 0 is less than 2? Yes. That means 0, 0 is a solution, which means every point that's near 0, 0 on the same side of this line should be a solution. So that means this red area is actually our solution set. Okay? Pretty straightforward problem there. So just test a point, see if it works. If it works, shade towards that side. Now remember, let's say I tested the point, -3, 2. Okay. Now remember, we know the shading is down here, so this point shouldn't work. When I plug in -3, 2, what do I get? All right, I plug in 2 less than or, 2 less than or equal to x. So -3 squared plus 3 times -3 plus 2. I get 2 is less than or equal to, that's 9, minus 9 plus 2. Is it true that 2 is less than or equal to, what did I do wrong here? Oh, sorry, this wouldn't be -3, 2. This would be 1.5, 2, because this is -2 and this is 1 and this is 0. So this is -1/2, 2. So -1/2 shouldn't work. -1/2 is 2.25. That's going to be minus 4.5 plus 2. So we get 2 plus, that's 4.25. We get -0.25. So no, 2 is not less than 0.25, which means that is in the bad region. So do not shade towards that region. Shade away from that region, reinforcing why it's everything below there. Okay? All right, so that's all I got. Thank you so much for being here. We will see you next week. Thanks again.